Hey everybody, Mr. Lucitis here. Let's go through our lesson that we'll be doing self-paced. This one's on writing equivalent fractions using area models. So I hope you did well on the first trial there. I kind of like having those questions up front before we start the lesson just to see what we know and then get you thinking along the right lines. So today, talking about area models and equivalent fractions. Let's review fractions really quickly here. Remember, our numerator is how many parts we have, and our denominator is how many equal parts make up a whole. So in this case, we have 1 out of 2, or 1/2, which means we have one part out of 2. If we had 2 out of 2, that would be one whole. That's how we can remember our fractions. So when we talk about equivalent fractions, oh, there's an E missing there. That's weird. Let me write it in. Equivalent fractions. So in this example here, this is a model. We can see 1/4, so that's 1 out of 4 shaded in. It's equivalent to 2/8. We just split up this model of force into 8 pieces instead of 4, but we didn't change how much was shaded in. It's the same amount shaded in, so same value, but with more pieces. So it has 2 out of 8 pieces. So think about a pizza when we think about these. We're not changing how many pieces of pizza we ate. Uh, or sorry, we're not changing the amount of pizza that we ate. We're just changing, okay, it's 2 small pieces or it's 1 bigger piece, is how we can think about it. Let's go to the next one here. So here's some steps to writing equivalent fractions using area models. And you can review these in writing as well after the video. So we're going to use an area model to represent the original fraction, shade in the parts that represents the numerator. You're going to use the same area model and divide it into different parts. So it says you might also want to divide each section into halves or thirds. That's probably the easiest way to do it. I'll show you a quick example of what they mean by that. So up here, let's say we're going to start with a half because that's probably the easiest one to do. So this would be in half, right? And we're going to shade in the left half. So that's to show 1 out of 2. So this is the fraction 1/2. And then to split this up further, let's say I wanted to split it into eighths. Well, sometimes the easiest way to do that would be to first split it up into fourths. So I'm going to put another line here, then another line here. Now I'm in fourths. Okay, and to split it into eighths, I would probably go the other way because now it's in 4, and I know 4 times 2 is 8. So if I split this across this way, now there's 1, 2, 3, 4, 5, 6, 7, 8 pieces, and there's 4 of them shaded in. So that shows me visually that 1/2 is equal to 4/8 because I didn't change the value, but I split it up into a bunch more pieces. Okay, let's go to the next slide here. Here's another example that they've done. They did 1/2 as well and 2/4. This one in a circle model. So use this technique of splitting it in half, then splitting it in half again. That's sometimes the best way to do it. Not always, depending on the denominator that you're comparing, but it does work well for 2, 4, 8, things that are double what your original fraction are. Here's our common mistake that we've seen before. We're not comparing the numerators, remember. We've got to look at both the numerator and the denominator. So in this case, 1/4 and 2/8. Well, if we just looked at the numerator, we would think 1 and 2 not the same. So these can't be the same, but in fact they are. Because if I look at the denominator and the numerator, I can see that both of these have a relationship. If I were to multiply them by 2, they would equal here. So that means that my model would have twice the amount of pieces is really what that 2 is saying. Oops, sorry, I scrolled away. Um, we want to make sure that anything over itself, 5 over 5, 3 over 3, 2 over 2, 105 over 105, they are equal to 1 because they are all the parts in that model. So if we have all the parts shaded in, we have a whole number, no matter what um, those numbers are. All right, so go through and enjoy this. There's a game to play next, a fraction matcher game, which will take you to a different site. Then you have another quick one to do on your own, and then we're also going to get into some practice with your learning coach. So there's, I think, 3 slides. Let's see, 1, 2, 3 slides to do with your learning coach. Make sure it says partner here, but when you're at home, use your learning coach as your partner, and make sure you're understanding what's going on before you move on to